Hello, everyone. Thank you for being here. I'm very excited to be with you today in this amazing conference. I was part of it last year, so yeah, I'm pretty excited to be back. And today I'm going to be talking to you about web machine learning using TensorFlow.js. So I will share some code with you, and we're gonna do a demo. So hopefully you will enjoy it. Right, let me look for the mouse. Uh, Great. So, first of all, I'm going to tell you a little bit about myself. My name is Patio Callahan. I'm Venezuelan, but I live in the beautiful Scotland. My background education is in computer science and artificial intelligence. I'm the technical leader of the web team at Charles River Laboratories. I am also an ambassador for Google's Women Tech Makers program, and I am an organizer of the Google developer groups in Glasgow. And yeah, one of my favorite things to do is that I'm a volunteer teacher at Code Club, which is an initiative from the Raspberry Pi Foundation. And what I do there is that I teach kids from 10 to 16-year-old how to code. We do a lot of stuff with machine learning, and they are just brilliant and amazing kids. If you want to connect with me, or if you have any question or any comment after this presentation, you can scan that QR code, and yeah, you will find there my social media, and you can connect with me over there. All right, so that's enough about me. So I will ask you to go and open that URL, and what you will see there is all of the steps that you need to follow on the workshop. Okay, so I'm gonna leave it like for a couple of seconds, so just for you to have a look at the URL, and then what you will see is something like this. You will see all of the steps and everything that I'm going to explain to you today. I'm not going to go into the very detail of everything that is on that website because of time, but you can feel free to go back and have a closer look at and read in detail everything that I'm going to explain to you. This website was made by one of the kids at my code club, so I'm very proud of them. All right. So, what is it that we're going to be doing in this workshop? So, well, basically, we are going to use a pre-trained TensorFlow.js model that is called Coco SSD. And what it does is that it detects objects it can be in a picture or it can be in a webcam stream, and it detects those objects, and it will draw bounding boxes around it. And it's not only going to do that, it will also tell us what is that object and what's the level of confidence that the model is actually recognizing that object of correctly. So this Coco SSD model is based on the Coco data set, and it recognizes out of the box 80 common objects. I will share with you later what are the objects that are part of this data set. So what we're going to do is that we're going to create a very simple website that will load it will detect the webcam from the device, and it will load the stream of the webcam and then identify in real time all of the objects that are there. So yeah, as you can see here on these images, you can see that it recognizes people, it recognizes a dog that you almost cannot see it there. And then at the bottom, you will see my friends from the Google developer groups in London that they were helpful and decided to be part of this and show their pictures. All right. Okay, so the amazing thing using TensorFlow.js is really really cool. And one of the most amazing things about it is that you can actually do so many different stuff, and with a little bit of creativity and the current knowledge that you might have about web development, you only need to have working knowledge of JavaScript, and then of course HTML, CSS. You can do very fun stuff or very useful stuff as well for maybe your work or some project that you have. So for example, there is this particular application that it actually uses the same model that we're going to be seeing today. So this is a smart webcam for a pet cam. Um, and this guy created this app um, to use in an old cell phone. And what it will do is like you have to enable the webcam on the cell phone in this web application. You select which of the pets you would like to recognize. Can be the dog, can be the cat. There are several, no, some animals that you can recognize within the Coco SSD model. Then you want to recognize as well an object. You can select a football, or it can be a bottle, whatever. And then you can start the selection, right? As soon as the pet gets into the same frame where the ball is, let's say the football is, you can get like an alert saying, oh, the dog is being naughty, he wants to eat all of the cookies, or whatever, and get an alert. So that is actually, a very fun project, but it can illustrate the kind of things that you can do that can be very simple, but they might be useful. So maybe you can do, I don't know, a smart pet feeder, and you can connect it to a Raspberry Pi, for example, and it will maybe automatically like dispense the food to the pet. So yeah, there's a bunch of things that you can do with this particular model. Remember, it recognizes 80 objects. Okay, so let's get started. So the first thing that I'm going to ask you is to go to the step 1 of the code lab. And there is a lot of text that you're going to see there. And again, I'm not going to read everything to you, but I'm going to give you like a summary of what that step contains, and the key things that you need to know. And again, of course, after this, you can go back and have a look at it and in more detail if you want. Okay, so you're in a step 1. And let's talk about what is it that you will learn, and what is that we are going to do, right? So we're going to build a website, a web page. We're going to use machine learning in the browser, and we're going to be talking about using machine learning in the browser more, and all of the benefits and the advantages to use it. And we're going to be classifying objects using the Coco SSD model. And then we are going to draw bounding boxes around each of the detected objects. And you will learn how super easy is to load a pre-trained TensorFlow.js model, how to get the data live from the webcam on your device, how we are going to classify an image from that camera to find the objects, and how can we highlight those objects that were found. Okay, so now I'm going to ask you to go back to the code lab and open the step number 2. And again, I'm going to give you a summary, and let's talk about what is TensorFlow.js. So TensorFlow.js is an open source machine learning library that runs everywhere where JavaScript can run. And if you know about web development or not, you can use JavaScript in many different sizes and many different places, on the client side, on the server side, and in many different kind of devices. So that is actually a amazing benefit being able to actually use machine learning with JavaScript. So these are the things that we can do with TensorFlow.js. Essentially, it allows you to run existing models, maybe pre-trained models, of course, that are being done in TensorFlow.js. We can convert models that were done with Python or maybe TensorFlow Lite. We can also do transfer learning, retrain the model with transfer learning, and you can write your own machine learning models completely from scratch. And what do we mean when we talk about transfer learning? For those of you who are new to machine learning, so it essentially means that you can take pre-made models that maybe were done by someone else, and you can retrain them with your own data. So if we have a model that, let's say, detects cats, I can retrain that model to learn to recognize dogs by giving it like a deep training data. This is a very simple example. But the whole idea, the good thing about this is that it allows you to make things and prototypes much faster, right? Because you're not making the model from scratch. Okay. And like I told you before, because TensorFlow.js is a JavaScript library, it supports all of these environments. And well, of course, you will not see here all of the browsers, right? This is just a subset of all of the browsers that you can use. But yeah, it can run everywhere that JavaScript can. We can run it in the browser for the client side. On the server side, we can run it using over Node.js. Then on mobile, we can use React Native. We can use it on progressive web apps. On desktop native, we can use it via Electron. And on my favorite way to use it will be on Internet of Things using a Raspberry Pi. Of course, using through if Node.js is supported on that specific device. And JavaScript is one of the very few languages that can run across all of these devices without any additional plugins or add-ons, right? So just for that reason, doing machine learning with JavaScript is a really interesting use case. Okay, so now let's see what are the client-side superpowers of TensorFlow.js. So doing machine learning in the browser, in the client side, let's talk about the client side for this part. So first of all will be high privacy. So and this is because none of the sensor data from the device of the user is going to be sent to a server for classification. All of the classification made by the model is going to happen on the device. So that means that obviously the data stays private. So in the example that we're going to be doing today, all of the classification will happen in my browser or in your browser. So the video or the images, they are not being sent anywhere. So that's amazing, obviously high privacy. Then the second point will be lower latency. And that is because there is no server involved. We don't need to send the data to the server and then wait for the round trip to come back to the user device. So obviously, and then maybe gather the data again and do the round trip again. So obviously the latency is lower, of course. And the third point is that you have the reach and the scale of the web. So anyone, anywhere, no matter the background, the background, they can open a website and enjoy the benefits of machine learning right away in the web browser. They don't need to be machine learning experts or data scientists. They don't need to have additional resources on their device, obviously depending on the model, but or very expensive hardware. They just can enjoy it right away, as you will be able to see today. And then, of course, there is a lower, one of the benefits is that the lower serving cost. So, of course, you don't need to, you can just host it, depending of the model, of course. They can be very small in size, so you can just host it as and serve it on your web hosting service, and it's going to be downloaded very fast. It's not going to, you don't really need to have a lot of resources. Obviously it depends on how many people, like you will need to worry on how many people is going to be using your solution on the web, and then you have to so on. But for using the model, is really, you don't really need a lot of serving costs, serving you don't need to have the server with expensive features in order to be able to use the model and host it. All right. And of course, we also support Node.js for server side and IoT, Internet of Things devices. Okay. So I will talk a little bit about the architecture, kind of. Well, let's talk about all the APIs that TensorFlow.js supports, right? So on the top layer of APIs, there are the models, the pre-trained models, like the one that we're going to be seeing today. So basically, those are ready to use JavaScript classes. Then we have the layers API, and this is like, it has like the higher level building blocks. Okay. So this over here. Okay. So yeah, these are the blocks that we can use to build and train our model. Then the third level, it will be the core ops API, and this is where you control like the model architecture, and it has all the mathematical side of it, the linear algebra calculation, and so on. So okay, let's take a look a little bit at how TensorFlow.js is actually created and what's going on behind the scenes here. Okay, so in this lower level API, right, lower level, it understands, like it will talk to different environments, like for example the client side. And as you can see here, we have the browser, or maybe a progressive web app in this example. And now those environments, they can talk to different backends. But when we talk about backends, it's not the server side. It's just the TensorFlow.js backend, which is like the hardware where it's being executed. Now, TensorFlow.js supports several different types of backends on the client side, let's say in the web browser. So let's say the first of all will be the CPU. So every device that's a computer has a CPU. And that's always going to be available for us, but is the slowest form of execution, right? Then if we want to go faster, we can use WebGL, and it allows us to get like the acceleration from the graphic cards. and we can execute our models over those. And we also have WebAssembly support, and obviously that gives us a faster execution on CPU devices as well. So it's a very, very fast performance. There are new ones, but I'm not going to be talking about those today. But we have some new options, especially on Chrome, that allows us to go way faster. Okay, and now from the server side, like I have been telling you, we can use Node.js. And just to let us know how this is done, it actually got two backends that it can support: the TensorFlow CPU and the GPU. So all that maybe you need to know here is that these are written in C++, and actually they are the same backends that TensorFlow Python uses. So TensorFlow running on Node.js will have actually the same inference performance as Python. And some people say that it can be even faster because of the just-in-time compiler of JavaScript. So yeah, that's pretty interesting. And now let's talk about my favorite part, which are the pre-trained models. So for that, I will ask you to go to the step 3 of the code lab. Okay. And let's talk a little bit about the pre-made models that are available in TensorFlow.js. So the team, the Google team that is in charge of TensorFlow.js, they are constantly working on new pre-made models. So you can, there are different categories. We have the ones for vision, human body, text, sound, and then we have like a more mixed category. So for vision, there is one that will classify an image, and there's another one for object detection. That is the one that we are going to be seeing today. For the human body, there is one that for body segmentation, it will show where, like it will highlight the arms, the head, and so on. Pose estimation, it will also highlight the position of your arms, of your legs. One kid at the Code Club, he created a very simple website. He's a black belt. He's 14. He's a black belt in karate. So he created this very simple website where for the little kids in his karate group, for them to practice at home the kata moves, which are very specific poses. And what it will do is that it will show the image, like it will show what is the kata that they need to do, and the kids will do it in front of the webcam and then the model will analyze if that pose is correct, and it will send a message that is correct or not. So very simple, but a kid was able to do that, and it was actually very fun to see he and his pals and his sensei making the training data for the model. It was really cool. Then there is one for face landmark detection. So it will find a bunch of different like points on your face, like the eyes, the smile, and so on. And usually this is used for filters and that kind of fun stuff, but not only for that. And then the hand pose estimation, that is actually another one, very cool. One of the girls in the Code Club, she did a small application to recognize hand language. So that was also really nice. Then on the text, you have pre-made models to detect text toxicity, sentence encoding, bear Q&A. Another girl did a very small website. Well, you will paste, let's say, a test into a text area, and then you can ask questions, and the model will return possible answers to that question based on the content of that test. And then it's the conversation intent detection as well. For sound, speech, command recognition, you can train it maybe with your voice, with some commands, and it will do something. So, for example, this is really nice. It can have really nice applications, let's say for accessibility. And maybe you cannot use your arms, but you can use your voice to navigate through a website or any kind of application that you can think of. And then the KNN classifier, I will not talk in detail about that. But you can go and have a look at in the TensorFlow.org/JS/models. I'm seeing that in the slide. You almost can see it. But yeah, you can visit there and you will see more information. Okay, so what are the benefits of using pre-made models? So of course, you don't need to gather the training data yourself, and because that has been already done for you. And this is very expensive because it can be expensive to get the training data. Then it can be very expensive to actually train the model. That depends on, of course, what you want to do. But yes, this is where you can spend most of the time and the money, right? So this has been done for you. You don't need to worry about that. And then step two, well, essentially rapid prototyping with a lower cost, of course, is achievable when using pre-made models because all of that hard work was done for you. So you can just start right away trying your idea and maybe testing it with the users. Um, you will use the state of the art research, and this is, of course, you have Google and supporting this project, and of course, those amazing guys that are part of all of the Google AI teams. It's also easier to use some good documentation. Again, I will highly recommend you to go to the website and have a look at it. And you can use transfer learning for some models, not all of them, but for some of them. So, okay, again, let's talk about what is Cocoa SSD. Again, is a pre-trained model that can help you to recognize objects. You can have several objects in the same image. So it's trained on the Cocoa dataset, and that dataset was gathered by Microsoft. And it uses a single shot detection architecture. So for each frame, it will recognize all of the objects there that are part of the Cocoa dataset. Let me see if I can show you here a little bit, actually, that dataset, so you can see the classes. I'm not sure you will not see. It's sharing the. Okay, I can. Okay, here it is. So these are the classes for the Cocoa SSD, but you will see like can be a person, bicycle, a train, a truck, a cat, a fork, a knife. So 80 objects, refrigerator, book, and so on. You will be able to find these on the documentation. Okay, now let's go back. All right, I move this here, and I have to click this one. Sorry, my connection is not the best right now. All right. Okay, so that's the Cocoa SSD model that we're going to be using. So now let's get to the setup. And I'm going to ask you to go to the step 4 of the code lab. And if you don't have a web server set up on your local machine, you can go to Glitch, and Glitch is a website where you can run a web project right into the browser. You can actually edit the code there, and you can see the changes maybe on a tab, another tab, or on a preview pane. So I'm going to ask you to go there, and you will make a copy of the project, like the boilerplate. Okay, and if you go there, this is what you're going to see. So you just have to click remix your own, and it will create a copy of the project on your, and you have to open a Glitch account. Okay, so then I will ask you now to go to the step 5, and you will see there the steps that you need to follow. But what I'm going to do is that I'm going to explain a little bit of the code, and then you can follow along. All right, so I will ask you to copy the code that is on that step 5, copy it over, like delete everything that is on your index.html file in Glitch. Remember, you copied you made a copy of the project that I shared with you in Glitch, and now you will have your own copy. You will go to the index.html file, delete everything, and copy the code that is on the code lab. Okay, and I'm going to explain a little bit about what do we have there. So first we have the just HTML, right? We have the head tag with the title, with the meta tag, and we are also defining where we want to include the style sheet, right? With all of the styles for our project. Then we're going to have a section which I did demos. And what it does is that there we're going to show the button to enable the webcam, and then we're going to actually show the video that we're getting from the webcam. Okay. And right now it has that section called demos. It has a class that is called invisible. And that is because we want to gray out, like disable the button until because we want to wait until the model is actually loaded on the web page. Because if we click the webcam button before the model is loaded, it's not going to work properly, and then it will be like a mess. So that's why there is that class invisible, but we will see it working. Okay, so this is like the only thing that you have to do to include, to be able to use TensorFlow.js in your web page. You just have to add a script tag, and you will import the TensorFlow.js library, which is just making the call to that URL on the top. And after loading TensorFlow.js, you'll want to load actually the pre-made model that you want to use. So after that, we're also including in a script tag the URL to the Coco SSD model, right? So you are going to be able to find the links to these CDNs on the documentation. And lastly, we add our own script because we still want to do some stuff with it, right? So we are adding the path to our own JavaScript file. Okay. If you go to the step 6 on the code lab, you will find the CSS. So I'm not going to go through the CSS in detail. I'm assuming that you have you're familiar with CSS. But I'm going to talk about just a couple of things. So again, I want you to do the same. Go to your Glitch project, delete everything that is on the style.css file, and copy the code that is on the code lab. All right. So if you do that, now you're going to see that everything is going to be grayed out. And if you open Glitch, let me open it over here. and I'm going to be doing this with you. You can preview the code that you are working. Okay, this is very slow. Okay, I'm going to share this tab. Oh, and it's not finding this one. Let's open this one. Okay. So what you can do when you are working on a glitch project is that you can click View Source. I'm very sorry, my internet connection today is very, very bad. Super slow. Okay, I'm going to remix it. Well, on the button, you will see a button that says Preview, right? So if you click Preview, you can preview on a new tab or preview on a pane at the right hand. So previewing there will allow you to see. Yeah, it's taking a long time. Well, I'm going to go back to the presentation. If you click the preview pane, you will see everything that you're copying. Like when you are editing the code, is going to be updated right away, right? On that pane or the other tab. Okay. Let me see. All right. Okay, now let's go to the JavaScript part. All right. So you're going to do the same from the step 7 of the code lab. So you will open the step 7 and you will follow the instructions there. But it's basically the same thing. You're going to copy code from there and put it on the script.js. Everything is you will follow step by step on the code lab. So let's talk a little bit about the code, right? So the first part of the core of the code is simply defining a bunch of constants that are grabbing references to all of the key elements that we are using in our HTML. So the first one is a reference to the video object that will have the stream from the camera. Then we have the container, we have the demo section, and then a reference to the button that enables the webcam. Okay. Then what we're doing here is that we are checking, first of all, we're checking if the device from the user we can access or if it has the media that we want to use, right? So if we have access to the media devices, let's say the webcam, it will check that. If it's supported, then to the enable webcam button, we're going to add an event listener, which is click. When the user clicks that button, we will execute this function called enable cam. This function here called enable cam. And if we don't have access to that, we can show, well, in the code, it just prints a message in the console that says that get user media is not supported by this browser. We can add any other kind of alert, right? So, okay, the next thing that we're going to do is to have a look at the enable cam function. Okay, so we already checked for webcam support. So now we are going to fetch the webcam stream. So we go to that function, enable cam, we pass the event, and we want to check if the model has been loaded. because if not, we don't want to start executing the predictions because it will not work, obviously. So that's the first thing that we can check. All right. If not, we're not going to enable the cam. Then we are going to remove the button because we don't need it anymore. So we click, we enable the webcam, and we remove the button. All right. Then we have a constant that is called constraints. And what it does is that we will tell if we want to use the video and the audio, but we just want the video to recognize the objects. We don't need the audio. So that's why, and it actually can create like a feedback. So in this constant, we're just saying we just want the video, right? And then we want to activate the webcam stream. So we go to the device, we say, okay, we want to get the user media, and we just want the video. And then we can start getting the stream from that webcam. And that stream, we're gonna assign it to the element video, right? And then we are going to add a listener to the video element. And what is going to happen is that, okay, if the event loaded data fires, we want to execute the predict webcam function. Okay. So now let's go to the prediction webcam function. In this part, this is empty because if you do this, you're not predicting anything yet, and you're basically pretending that the model loaded. So that's why the model variable, we're setting it to true. And then what we do is that we remove that class invisible. So if you do that, you should be able to see yourself. Like, of course, this is a picture, but if you're following along, you will be able to see yourself like in the cam, right? That's what you should be seeing right now. Okay. So now, but let's learn how to use the TensorFlow.js machine learning model. So you're going to do the same, and this is on step 8 of the code lab. You're going to do the same. You're going to copy the code into your script.js file, and let's have a look at that one. Okay, so right now we are creating the variable for the model, and because if we already loaded the model, if we included the Cocoa SSD URL, we can reference right away the Cocoa SSD class, the object, and then we're going to load it. And when it's loaded, the model, we are going to assign it to the model variable. All right, and then we can remove that invisible class that we added to the demo section. So we have our model loaded, okay? So the next step will be starting working on the predict webcam function. And as you will see there is an array that is called children. So what this array does is that when the model is doing the predictions and is drawing the bounding boxes, that happens with each frame that it analyzes, let's say. So in a video, you have, if it's just one picture, that's okay. But if it's a video, it's like one frame after the other, after the other, after the other, and so on. So because you can move, there can be new objects coming into the frame. So if you draw the bounding box using CSS right on the HTML, and then you go to the next frame, that bounding box is going to be there, right? And if you go to the next frame and draw another one, then you will have another bounding box. And as you keep on adding more frames, you will have a bunch of bounding boxes, right? So what you want to do is to keep track of each bounding box, and that you can remove them from the DOM, right, from the web page, when you get to when you get to analyze the next frame. So that's why we have that children array, because every time we draw a bounding box, we want to put it there so we can remove them from the web page for the next frame. I hope that makes sense. Okay, so on the predict webcam function, the model will detect the video, right? And then it will return the predictions. And let's talk about that. So here, what we're doing here in this part is iterating over that children array, and we are removing everything that is inside, right? So because we're removing all of those bounding boxes that we put in there, we are removing them, and we want to have like a new canvas, right, for the next frame. Okay, so in the predictions, what the model will return a predictions array, and the predictions array will have as many objects as as the model founds in the frame, right? And each object, per object, it will return the class name, which will be person or cat or dog. It will return these values for numbers for the bounding boxes, and it will return the level of confidence, right? The level of confidence is how sure it is that that's actually the object that is predicting, okay? So the bounding boxes, we get the X and the Y point. There's like the coordinates, and then we have the width and the height. And with those numbers, using CSS, you can actually be able to draw that box on the web page. Okay, so what we're doing here is basically iterating over the predictions array, right? We have let's say that there's 3 objects, a cat, a person, and a cell phone. So we will get 3, right? 3 elements within the predictions array, and we're going to iterate over them. So again, we will have the score, which is kind of the confidence percentage, the class, and the bounding box array. All right. So there you will see that there is a specific number, arbitrary number there, which is 0.66. And you can say, basically what we're saying there is that we want to get all of those objects that the confidence number is 66%. So we want to be super sure that the ones that we are going to highlight are over 66% of confidence. So maybe you can be it really depends on what you want to do, but it can be 90%. Maybe you just want to highlight those that have like a high confidence number. All right. And yeah, basically what we're doing next is creating a P element where we are adding in the inner text the name of the class, right? Which will be dog, with, and then we convert that number into percentage, level of confidence. And then we're going to style that P element with the margins, everything that we need, and the width and the height, everything that we need to actually draw the bounding box. All right. And then we're going to do the same, but with the highlighter. So the bounding box will be like the border, right? We can do just that. And then the highlighter will be like adding kind of within the box. We can highlight all of that area, and we make it a little bit transparent, right? Because otherwise we will not be able to see the object. And it's a better way to highlight the whole bounding box. And then, of course, by the end, because this is a video, we want to call it again. All right. We want to keep on predicting per frame that we get from the video. All right. And if you're testing, you will see that it works. And as I told you, the bounding box, you will see like that white dot line around the object, which will be me in this case. And then we created that P element, which is that orange bar with the class name, which is person, and that string with the level of confidence. Okay. And we just use 3 lines of code for the machine learning part, which is including the TensorFlow.js library, the Coco SSD model, and then, of course, to make the prediction, to call the model, to receive the prediction. And the rest, it was just drawing the bounding box and doing the browser checks to get to check if we are going to be able to access the webcam. Let's see if I can show it to you here working. In the meantime, let's see. We can continue on the next slide. So, okay. So what's next? Yeah, so like I said, you can open the step 9 of the code lab and you can have a look at what are the next step and what you can follow. My computer is getting frozen, which is highly stressful. All right, and let's just do a recap while I see if I can show you the model working. My computer doesn't want to help me out this time. Let's see if we can make it work. Okay, so let's in the meantime say, let's have a look at the recap. So you learned the benefits of using TensorFlow.js and the pre-made machine learning models. We created a fully working web page to classify common objects in real time. We created the HTML skeleton. We defined the styling that we needed in order to be able to create the bounding boxes. We detected and enabled the webcam stream, loaded the pre-trained TensorFlow model, used the model to make the predictions and the classification, and then we draw the bounding boxes. I think, yes, this is the one that we can use. Let me see. Okay, I just want to give you guys a preview. Let's see if we can use this one. Hopefully you're going to be able to see it working if you follow the steps. Let's see if unlock is really slow today. Okay, let's have a look here. All right. This one. Close this one. Yeah, apologize. My computer is really slow today. Let's see if we can show it to you before we go. We're running a little bit late. Okay, we have it here. It's very slow. What I can do is to send you the URL on my Glitch account. You will be able to see one project that is called, the URL is Alive Paint Timbleberry. And that one has all the code working. That's the one that I'm trying to open, but my computer is not helping today. All right. Okay, so yeah, that's it. If you guys want to get in touch with me, let me see where I have my slides. You can contact me on my social media. And here are all the resources that you can visit. So, for example, of course, the TensorFlow.js website. And if you want to have a look at the pre-made machine learning models, you can go to that URL. And this is amazing. If you follow that hashtag made with TensorFlow.js, made with TFJS on social media, you will see all of the amazing stuff that a lot of people is doing everywhere around the world. There are a bunch of really, really amazing, really cool projects that people like. The imagination of people is just amazing. All the innovation that comes with being able to use machine learning and to create your own projects without having to be a data scientist or a machine learning expert and so on is just amazing. And of course, I will also, yeah, I really wanted to give you an example. If you go to that YouTube playlist, you will see as well all the Jason Mays, which is the web machine learning lead in Google. He does this show, I think it's every 3 months, where he invites, it's kind of a show and tell. He invites people from all over the world to showcase the projects. And yeah, thank you so much for joining me. I really, really apologize. I wanted to show you, do a little demo of the project working, but my computer today, of course, is not, is being really, really slow. But yeah, if you want to get in touch with me, if you have any question, if you are doing something with machine learning, I would love to have a look at it. So send it over my way and I can share it as well with the Google team that is in charge of TensorFlow.js. And yeah, thank you so much for joining me and I hope to see you soon. Bye bye.